Hello friends, welcome to Techno Skill Up. Today we are going to learn about various delays in computer network. So consider two hosts, host A and host B. They are connected with a transmission media and we want to send some data packet from host A to host B. So, what do we mean by a delay? So, delay is actually a computer, means in computer networking, the time taken to send the data from sender to receiver, that is called delay. So, if you consider delay is the time taken from sender to receiver, sender to receiver. Okay. So when the packet starts from the source, it passes through some networking equipments like routers and then it reaches its destination. When it passes from one node to another node, it experiences different delays on its path at each node. So one thing we know that the performance of a network that that is actually measured in terms of delays, throughput and packet loss. Today, let us discuss more about the delays. So if you consider about the delays, there are four types of delays in computer network. First one is transmission delay. Transmission delay. Then second one is propagation delay. And then queuing delay. And the processing delay. Normally transmission delay we denote it as TT. Okay. So what is this transmission delay? For example, this is source A and this is destination B and they are connected with this transmission media. So actually it is the amount of time taken by the host to transfer the packet to the outgoing link. What is the meaning? For example, this is the packet. The amount of time this source is taking to put it on the outgoing link, this is called transmission delay. Okay, so consider one example like suppose you are vacating the house and then you have to put all the parcels or you have to load all the parcels to the truck. So the time taken to load the all the parcels to a truck, that is transmission delay. I am not talking about the truck will move from the source to the destination, that is a different delay, but the time taken to load the parcels into the truck, that is transmission delay. Likewise, the time taken to load this packet or to put this packet in this transmission link or outgoing link, that is called transmission delay. So let's consider there is the data is 100 bits. Data is 100 bits of data is there. 100 bits of data is there, and your bandwidth of the link is 1 bits per second. So if 1 bit of data which can be transmitted per second, then how much time it will take for the 100 bits? So obviously it is 100 seconds. So this is what the transmission delay is. So length normally we consider as bits and bandwidth is bits per second, correct? So if I want to find the transmission delay, that is for example TT, we consider this one. So it is like length of the data divided by bandwidth of the transmission, bandwidth of the transmission of the sorry of the transmission. Okay, so this is length. If I consider L, bandwidth is B, then this is transmission delay, and this is, as we know, bits, and this is bits per second, so it will come on seconds. So tt is equal to L by B. This is the formula to find the transmission delay for a packet. Okay, so what are the factors transmission delay depends upon? So this is very important to know about. So as we see that formula is transmission delay is directly proportional to the length of the packet. It means when the length of the packet increase, if it is more, then obviously transmission delay will be more. And then the transmission delay is inversely proportional to the bandwidth. When bandwidth is less, then transmission delay obviously it will be more. When bandwidth is more, the transmission delay will be less. Okay, so the most important thing is transmission delay is considered as milliseconds or microseconds. Okay, microseconds, correct. And then and when we talk about any bandwidth, this bandwidth should be power of 10. Okay, and this data should be power of 2. Okay, so suppose if I tell that this is power of 10, and this is power of 2. So when we talk about 1 kbps, okay, so it means 10 to the power 3, 10 to the power 3 bytes per second, okay. But for data, if I think about 1 kb of data, so it means 2 to the power 10, means 1024 bytes. Okay, so now 1 m means 1 megabits per second means 10 to the power 6 bytes per second, or if we consider as 1 mb, it means 2 to the power 20. Okay, or maybe 1024 into 1024 we can say. So that's it, that is for transmission delay. Let us discuss the second type of delay, that is propagation delay. Normally represented as TP, right? So this is sender A and this is receiver B. They are connected with each other with the transmission medium. Now this packet is at the transmission medium, right? So we call the amount of time this packet needs to physically move from sender A to receiver B is called the propagation delay, right? This is called propagation delay. So what is the formula for the propagation delay? If you consider, so it depends upon the distance between sender and receiver divided by speed of the transmission medium. So if you consider distance as d and speed as s, then the propagation delay is d by s. So now what are the factors affecting the propagation delay? As from the formula we can see the propagation delay is directly proportional to distance. So if distance is more from sender to receiver, then obviously this propagation delay will be more, and it is inversely proportional to speed of the transmission medium. If speed of the transmission medium is more, then propagation delay is less. If speed is less, then propagation delay is more. So these are two major factors of the propagation delay. Okay, so one point here to remember, that speed of the transmission medium of a optical fiber, transmission medium of optical fiber is approximately 70% of the speed of the light, that is 3 into 10 to the power 8. So this is 2.1 into 10 to the power 8 meter per second. This is the speed of the transmission medium of the optical fiber. Okay, so let's discuss some of the examples to understand propagation delay a little bit more. So let us understand from some examples. For example, this is sender A and this is receiver B, and the distance between sender A and sender B is 2.1 kilometer, and the transmission medium is a optical fiber medium. So obviously the speed is, as we discussed, it is 2.1 into 10 to the power 8 meter per second. So if we need to find out the propagation delay, that is d divided by s is equal to 2.1 into 10 to the power 3 meter, then divided by 2.1 into 10 to the power 8 meter per second. So this is approximately, this is 10 to the power minus 5 seconds. Normally the propagation delay, we convert it as millisecond or microsecond. So converting anything in milliseconds, we can multiply it by -3. So we'll divide it by -3. That is millisecond is equal to, it becomes 10 to the power -2 milliseconds. Correct. Now consider another example. For example, the question is find the propagation delay if a packet is sent through an optical fiber. So here they have mentioned the packet is sent through the optical fiber. So obviously the speed, indirectly they are telling, is to 10 to 2 to the power 1 into 10 to the power 8 meter per second, and the distance between sender and receiver is 5000 kilometer. It is very similar what we discussed in the previous example. So you can calculate Tp equal to d by s, that is 5000 into 10 to the power 3 meter divided by 2.1 into 10 to the power 8 meter per second. So you just calculate what will be the answer. Okay, so just remember that in propagation delay, normally we consider propagation delay in terms of millisecond or microseconds. Okay, this is the unit we use for propagation delay. Now let us consider the third delay, that is queuing delay. Okay, so what is this queuing delay? So when the packet received at the destination, normally it may not process immediately. So it needs to be wait for some time, and it is in the queue, means we can say in the queue it should wait, that is in the buffer, it should wait for some time. So the amount of time means, for example, this is sender A, this is B, and then now what will happen, so after reaching the packet here, so these packets needs to be wait for in the buffer for some time, or in the queue we can say. So this waiting time is called the queue time. Okay, this waiting time is we call is this as a queue time. Okay, about the factors of the queuing delay. So what are the factors we can consider? So first thing is, if the size of the queue is large, if this size of the queue is large, that the queuing delay will be huge, and if the queue is empty, then there will be less delay. Okay, so if more packets are coming very quickly from sender to receiver, then obviously queuing delay will be more. So these are the two factors for the queuing delay, but we need to remember that it is different for packet to packet, and there is no specific formula to determine the queuing delay. Okay, so the fourth type of delay is the processing delay. Processing delay. Processing delay. Okay, so processing delay is it is the time taken to process the data packet by the processor is called the processing delay. For example, so now this is sender A, this is sender B. Now the packets are in queue, and the packets are now in the queue, and now the processor will pick this packet and process it. Okay, so picking this packet and processing it is called the processing delay. It is called the processing delay. So the time taken when it will process the data one by one, that is called the processing delay. Okay, so for example, if it is a router, processing delay may be related to decide where to forward the packet, updating the TTL, to do header checksum. So there are various things is need to be done, and that is due to that this processing delay will happen. Okay, so it also depends upon the speed of the processor, and speed varies system to system, and hence means as it depends upon specific systems, so there is no specific formula for this processing delay. So now till now we have understand about the four delays, that is transmission delay, propagation delay, queuing delay, and processing delay. So if you consider about the total delay, so T total, if you want to find out, so total delay is the transmission delay plus propagation delay plus queuing delay plus processing delay. So this is the total delay in the network. Sometimes this total delay is also called as nodal delay. So just remember, sometimes in some reference you can see this as a nodal delay also, nodal delay. Okay, normally as we don't know about, there is no specific formula is available for the queuing delay and processing delay, so we consider this as this delay period as zero value. This is as zero and this is as zero value. So if you consider coming to this to total time should be transmission delay plus the propagation delay. Total delay time is, or nodal delay we can consider, thus it is the addition of transmission delay and the propagation delay. Okay, till now we have discussed sender A, this is receiver B, they are connected with each other, okay, in a transmission medium, and that amount of time to put this data into the transmission medium, that is called transmission delay. After this data is here, from sender to receiver, the amount of time it will take to physically move from sender A to receiver B, that is called propagation delay. After reaching here it should wait in the buffer or queue. Okay, so that is called queuing delay. Okay, so after this, system process will take it and process it, that is called processing delay. So if you consider the total nodal time or total delay or total amount of delay, so we need to add all those details: transmission delay, then propagation delay, then queuing delay, then processing delay. Okay, this is the total delay, and we have formula for transmission delay and propagation delay, but we don't have specific formula for queuing delay and the processing delay, as it depends upon system to system. So normally we consider this as this delays as zero. So total nodal delay is, addition of the transmission delay and the propagation delay. So that's it for today's video, friends. Hope you learned something today. If you like my video, please like, share and subscribe to my channel.